So, hello Jacek, hello Dmitry.
Hello, здравствуйте. Hello.
Let's have a small talk about your upcoming presentation. Jacek, you are an IT freelancer specializing in Apache Spark, Delta Lake, Apache Kafka, and Kafka Streams. How do you feel about that?
I'm feeling great. I've been doing it for the past 5+ years, and I can't think of a day without them,
Yeah,
honestly.
yeah, that's great. And Dmitry will help us with his expertise. Dmitry is working as a uh, maintainer of platform of recommendations in Sber. Dmitry, and what's your passion in your job?
Well, my passion in my job is our clients. I want to make the life of our clients better by providing more personalized, more relevant content as usual. We are a very client-oriented company.
All right, thank you. As a brief introduction to the upcoming talk, I want to ask one simple question. Let me describe one simple use case. In the meantime, there are dozens of companies who are starting to grow their own data, building some kind of data lakes, something like this. And in some cases, these companies even doesn't have the history of data management, and they don't need to ingest some traditional relational SQL databases into their Delta Lake and to their, yeah. So, for example, this is my case. I am personally in a such situation. And as far as I know, Delta Lake is more about transactions and something connected with the traditional SQL databases. So Jacek, please describe me this picture how Delta Lake can be used in such cases when there is no strong connection from the data lake to the traditional SQL databases.
Awesome. I'm glad that you asked this question because that's exactly the purpose of my talk. Introduce you and others, the audience, how to work and use Delta Lake. SQL is among the front end front end languages which you can use to describe your queries. If you are comfortable with programming languages, Scala, Java, Python, perhaps in the future, or you might be using them to describe all your data processing. Now, this is Spark SQL in general and Delta Lake in particular. So what's the difference between Delta Lake and Spark? Well, Delta Lake is just an extension of Spark SQL, to be honest, to be precise. And so you've got all these languages, SQL plus programming languages like Scala and Java, as well as time traveling due to this history or data lineage, as some may call. So whatever you are doing with your data, you are manipulating it. And by doing this manipulation, you want to make sure that you don't lose your data. And by saying you don't want to lose, well, you imply some kind of history. So you want to track what was your version 0, 1, 2, 3, 4, 5. And that's exactly Delta Lake. Delta Lake allows you to do this without much thinking about that you are actually doing it. And so you've got all the power of Spark SQL, plus some extra features that are available because of Delta Lake. And that's pretty much how you can use Delta Lake on top of Spark SQL workloads. And to address your question specifically, you don't need to have a relational database to use it. SQL is just yet another language to describe your queries, batch or streaming. and you don't need to have data, well, you can build it, during while you are building your platform better.
Thank you. That was interesting. And now let's move to your talk. Have a nice speech.
Thank you, Sergey. Okie doke. So here it comes, my presentation. So let me put it. Okay. So, ladies and gentlemen, let me make it full screen. Okay, so, and resume. So, здравствуйте, ребята. As I remember from my Russian lessons when I was at school. It's been a while since I spoke Russian, so pardon me, I'm not gonna speak Russian during this talk. And so this talk is about Delta Lake and the latest and greatest. I couldn't come up with a better name than latest and greatest. It's just to introduce you to Delta Lake and how to use it if you are a Spark SQL user already. If you're not, well, you should, or definitely you should consider this as a backbone for your data processing platform. I'm Jacek Laskowski, and this is my Twitter handle, Jacek Laskowski. So if you need me, DM me on Twitter or Telegram, and I'll be happy to answer your questions about this talk or any other talks I gave in the past. So I'm Jacek Laskowski, freelancer. I'm specializing in Apache Spark, Delta Lake, Kafka, including Kafka Streams, and some other tools that you may be using for something that they call data engineering, like Presto. I got interested in Presto, and because it provides similar features to Spark, so I got curious. How is it different from Spark, which I believe I know enough already. I'm available at this email address. I'm also available on Twitter, so if you need me, just ping me. And if it's about Spark, Presto, Delta Lake, Kafka Streams, I'm sure I can find some time to answer your questions and have a lively conversation. I'm best known by this, what I call internals of online books that are available on Books Yapila. That's about me. Okay, that was quick. So if you've got any questions, you may ask them in the chat window or chat under the window where you can see me. We can answer your questions during or after my talk. Well, it depends, how the flow goes. So, we've got moderators ready and looking at this chat window. So if they feel it's the perfect time to ask questions, they'll let me know. Thank you. So Delta Lake. So Delta Lake is an open source project. It's an open source project for bringing transactional storage layer over object stores. As you may have heard, there are cloud providers. There is Azure. Well, from my perspective, I'm not very cloud heavy or cloud savvy, so to speak. I just started my journey into cloud, but I hear about Google Cloud. I hear about Azure Cloud. I hear about Amazon Cloud. There are others, and all of them provide something that they call object store. It's almost like file system, but it's not file system. We got used to working with files. Now we need to think in terms of objects. And these object stores, this so-called file systems, object-like or file system-like object stores, they are eventually consistent. So they bring some complexity to our thinking. If our thinking is how to say, influenced by file systems. And in my case, yeah, it's the case. So this transactional storage hides the complexity of working with object stores and brings something that you may have enjoyed while working with SQL databases, transactions, ACID transactions. This is the beauty of Delta Lake. you are working with big data. Now you are manipulating big data to produce even bigger data. And if it's transactional, well, it couldn't be prettier, right? And since we are speaking about transactions, about modifications to your data, well, it'd be nice if the platform provided something Delta Lake calls time travel, and that's among the features of Delta Lake, bringing you transactions, allowing you to modify your data, and if you are fine with modification, fine, you can move on. But if not, and if you wanna, change something, what was available before, well, time travel may be of some help. So these are the two main features of Delta Lake, but they are not all. We've got also something Delta Lake users refer as scalable metadata handling, like schema enforcement. So you make sure that the data that's coming in is of particular schema, as well as schema evolution, which allows you to evolve with your schema to accept more and more data of different shapes. What I like about Delta Lake is that Delta Lake supports streaming and batch data processing. Delta Lake is an extension and fully compatible with Apache Spark APIs. For myself, and for people new to Delta Lake, and if you have some background with Spark, you can just think about Delta Lake as yet another data source or data format. It's just like this. By plugging it in at command line, you can enable cool features like ACID transactions, time travel, and this scalable metadata handling for free. Okay, again, this is open source project, so although there is commercial version of Delta Lake, you don't have to use it. You can just stick to open source and be fine and just use these features I listed. Okay, in short, if there was one sentence out of this slide that I'd be happy you to remember, is that Delta Lake is just an extension of Apache Spark. Okay, with all the goodies of Spark SQL plus some extra features. So let me introduce you to Delta Lake by showing you first demo. So this presentation is going to be slides with some demos. I've got 5, if I'm not mistaken, 5 demos of various complexity. Your questions are supposed to narrow down to things you might be needing or you might require for your platform. So please keep asking questions so I can deliver the best presentation ever. Okay, so during this demo, I'm gonna show you how to install Delta Lake in your Spark application. And by saying install, in mind that I use quotes, it's because, well, there's not much installation in transitional sense. Well, Delta Lake is just an extension of Apache Spark, so minus packages on command line is all you need, okay? I'm gonna show you how to create a Delta table using Scala. I'm Scala developer most of the time, Scala as well as SQL for people who are data/SQL savvy. And I'm gonna show you how to read and write to a Delta table by using 2 APIs available in Spark SQL and Spark Sector Streaming for batch and streaming queries. Okay, so let me open up my terminal. Hope you see it. And this is what I'm gonna show you now. So I'm gonna open up my Spark shell, and by when I said I'm gonna install my Delta Lake, this is all you need for Spark application. Well, in this particular case, I'm gonna use Spark shell, or I'm using Spark shell, which is just command line version of any other Spark applications you could write yourself by using minus packages, IO delta core _212 for Scala version, it should be compatible with. And this 070, this is the version of Delta Lake. This is all you really need to enable this extension. Then, if you are into, well, some catalog-like operations with SQL, just spice it up with these two configuration options. Spark SQL extensions. This is something you have to remember. Yeah, basically, kind of like boilerplate. And --conf Spark SQL catalog Spark _ catalog. This is the name of the default catalog. And by plugging it in, plugging in Delta catalog, you make this Delta catalog the first entry point to any catalog oriented calls, basically allowing Delta Lake intercept all the SQL table related calls and do all the nice things you basically need by installing Delta Lake. Okay, so as they say, without further ado, let's give it a go. I'm running Spark 301 for people who are familiar with Spark. Yeah, it's something that you can see now here. This is in local mode. I don't bother with installing it on any cluster manager, be it Spark standalone, Kubernetes, or Yarn. It would not add much, but definitely it would make it more complex and perhaps even less, how to say, fail immune. So Scala version 2.12 on Java 11. Okay, so pretty recent stuck, and hopefully we don't get stuck while doing all this. So first of all, we need to we installed Delta Lake. So again, this is Spark version. I've got my cheat sheet. So let's create our first Delta table. Okay, so Spark range and Spark range 02. It's to create data. It's just fake data. You could just read from a relational table or non-relational table or from HDFS, S3, whatever, okay? So you've got your data. Now, you write this data in Delta format. This is the moment where you say, hey, Spark, whatever I'm gonna do now, I'm gonna do it with help of Delta Lake. So format Delta, and then you can just save, and this is location of my data. It could be HDFS location, Azure Blob Store, or Google storage, or whatever you are using for large data sets, huge data sets. I'm just simply using a local file system. It's okay for demo. I hope you don't mind. And so I just created. Let me just show you that this directory does not yet exist. Okay, so no such file or directory. Okay, and I just press enter to write to record a data set. Okay, so I did this. Okay, and by looking at this stack trace, I apologize if there are too many characters to read in now. Well, we don't have that much time to discuss all the lines, but basically, I just created a versioned table using Delta table, okay? The Delta Lake, sorry, Delta Lake. So I basically created initial version of my Delta table. Okay, and by enabling all this low-level information, well, for me and perhaps for you too, it gives extra information because we are interested in this low-level bits and bytes. Okay, so I save it, and under this directory, which is now available, you've got basically this little directory called _delta_log. Whenever you see _delta_log directory under a directory, you can consider, and this is how Delta Lake, you can consider this directory a directory of a Delta table. This is how Delta Lake recognizes a directory that's managed that should be managed by well, Delta Lake. Okay, so this is kind of like a magic number, magic directory, which is hard-coded in Delta Lake source code, which says, hey, Delta Lake, yep, you are working with Delta Lake table. Okay, what's inside? We go to it in a sec. Okay, let me read this table. And important information is that you need to remember that whatever you did using Delta Lake, you should read as a Delta table too, using Delta Lake. Why am I saying this? Well, the reason is that under the cover, Delta Lake uses Parquet format for storage, for saving, for storing data on file system. It means that you can mistakenly, and it's correct in a sense that, well, it's a Parquet table, you can mistakenly read it as a Parquet table. The difference between Delta Lake using Parquet format and Parquet support in Spark SQL is that, well, you are losing all the goodies that come with Delta Lake, like time travel, transactional support, and others. Okay, because, well, Delta Lake is layer atop your object store file system. Okay, so Spark read format. This is something you can configure to be the default file format on your for your Spark application, so you can just remove it. I just kept this on purpose so I can repeat it over and over again so you don't forget. Okay, Spark read format dot, and now I'm just pointing at this directory where I save my table. So I basically just copy and paste it here, and I do show. Okay, and I'm expecting 2 records because, well, I just saved 2 records. Nothing really fancy. Yeah, I understand. Okay, so now I said that you could read it as a Parquet data set, and so I'm gonna change it. Parquet is default file format in Spark SQL, but for the sake of this presentation, I'm gonna use Parquet explicitly by using the same format method, just like what I did for Delta. Okay, let me read it. You see, nothing really changed. Okay, where the difference between Delta Lake and Parquet lies is that you get another layer atop your Delta table, another layer with every modification to this Delta table. So, but we get to it, okay? If not, you ask questions and then I repeat this or that again. I'll just say, because repetition means that I said it, but I assume that I might not. Okay, so I'm looking at, so something that's really cool is that every modification, every version, every transaction makes a separate version of your Delta table. So what I'm going to do now is to start another terminal. Okay, and in this another terminal, I'm going to use another Spark application. Well, it's just a coincidence. Well, not really, because I'm using my computer, but it's just a coincidence that I'm using the same laptop, the same computer to run 2 separate Spark applications. Just imagine that you could just run these 2 applications separately on different hosts. So by doing this, I'm pointing these 2 applications to the same directory, at the same Delta table. And by doing this, I'm gonna show you some other cool features of Delta Lake. So what I'm gonna do is that I'm gonna read Spark, read stream. This time I'm gonna format, and then Delta. Okay. Now, when I'm reading this table, so what kind of table? Well, I'm gonna do load and simply copy it here. Okay, so I'm loading. Then I write stream. Okay, in format console. I'm gonna explain what I'm typing in a sec, and just start. Okay, so before I hit enter, I'm gonna explain what I just typed. So Spark Read Stream is an entry point to streaming capabilities of Spark SQL, which basically is Spark starts streaming. By saying format, I'm using this format to load dataset that's available in this directory, which we know is a delta table, which we just created. Then I'm just writing this stream. So whatever I loaded as a stream of data, I'm gonna write to the standard console. That's what it means, format console. And I just start this infinite loading of my table, delta table. So hop. So loading version 0, as you can see. So I'm reading this version. It tries to, pre-process this data and show me the very first batch. Okay. So it took some time to, warm up. After this, you will see here all the batches. Well, batches of changes to my delta table. So now, well, let me show you how to write new rows. In other words, append new rows to my delta table. So by doing Spark range, previously we inserted or we saved 2 rows. Now let me insert rows from 2 to, for example, 4. Then dot write in format Parquet. Well, no, not Parquet. Come on, delta. Then not write. I need to mode append. Otherwise, I would get exception, which I just skip. If you are interested, just remove mode append, and you will see that you are accessing a directory that's already available. And then I just save to this directory. Okay, so this is to add 2 new rows to this 2-row delta table. Okay, let me hit enter. Hop. And as you can see, you've got batch 1 that says these 2 new rows were added to this delta table. So, well, you can do whatever you want in this streaming pipeline after a change or changes in your delta table. So you can intercept all the changes to your delta table and simply react in a proper way, in your business savvy way. Okay, so what I showed you is how to read using batch streaming modes, as well as how to insert and intercept all the changes using streaming query. Okay, now if it were an interactive session, I would ask, are there any questions? But well, let's move on, okay, and wait till I get interrupted by some interesting questions. Okay, so by the way, before we leave this demo, I'm going to show you something really cool. Let me check if I can show you. Yeah. So display history. Okay. So while doing these changes, this insert. Well, basically, I just inserted 2 new rows. Basically, having 4 rows now. Let me check it. So I'm going to read the latest and greatest of delta table that's available in TMP delta 01. So how many rows we will have? Well, 4, because we started with 2, we added 2 more, so we've got 4 rows. And for many of you, it might be, what's the fuss about saving 4 records using Spark SQL and Delta Lake? Well, ladies and gentlemen, first of all, we had the streaming capabilities of Delta Lake, and we could react to all the changes. And now, ladies and gentlemen, comes something very nice, because by using, well, interface of Delta Lake that's available in Delta, tables, and Delta table, you can just do something like this. Delta table for path, And this path is exactly the one we are using for Delta. And then we simply enable management interface over this directory using Delta Table API, management API. So among management features is history. And I'm gonna show you the entire history truncate false of this table. And as you can see, there are two versions of my Delta table. So if you don't believe me, well, I make it more readable by using select and just using this version. Yep, a version. And look at this, two versions, 0 and 1. The obvious question is how to access each version separately. Is it possible? Yes. How to do this? It's coming. Okay. There are other features, but I just skip them for after we have slides. Okay. So let me change to my slides. Where's my presentation? It's here. Okay. So in this demo, I showed you how to install Delta Lake, how to create Delta table, and how to manipulate it, keeping track of all the changes. Well, I haven't showed you how to keep track of all the changes, except that I showed you that streaming query can intercept these changes, as well as there is some notion of history, and I showed you how to see it. Yeah. So Delta Lake. So what is Delta Lake now after we saw this demo? So in Delta Lake 070, which by the way requires Apache Spark 3.0, and I use this combo Spark 3 plus Delta Lake 070, we've got better support for Metastore, aka catalog. Okay, so we've got, so Delta tables are now registered in Metastore, kind of like Hive or Spark native tables, similar to Hive or Spark native tables. So by plugging this Delta connector catalog, we simply add this extra feature of having Delta tables registered in catalogs, Metastore. So now we can just use it as if Delta tables were Hive or Spark tables. So what it gives us, we've got this DDL support for create table, alter table, insert into, delete, update, merge into. All these nice SQL features, SQL commands that you may have been using in the past for relational or non-relational tables, databases. Now you can leverage the power of these commands in or for Spark, for Delta Lake atop Spark SQL. So again, we are thinking in terms of SQL, but it's not about relational databases. It seemed to be like working with relational tables or databases, but it's not. It's about big data through SQL lenses, so to speak. There are also some custom SQL commands, which I'm going to show right now. So they are described in my internals of Delta Lake book. So among them are convert to Delta, so you can convert Parquet table to be Delta table, describe detail, something that I'm going to show in a sec, describe history, something that you have seen already, but by me using Scala API, not SQL. So SQL variant is coming. Generate, this is for integration with with external systems that require some extra files that would describe what data is stored and where, and vacuum to manage history, how much history, how many historical entries we keep in our version history, just like in Git. so you can vacuum something that you no longer need. After, for example, 2 years, you can decide that all the versions after to be 2 years old can be vacuumed. Simply means deleted. Okay. Okay, so I close this and go back to my presentation. So, yep, and let me move this presenter view here. Okay, so now, ladies and gentlemen, let me do another demo 2, to do all the niceties that I showed using Scala API, but this time I'm going to use just good old SQL. So again, after our opening chit chat, you may be thinking, if it's SQL, it's relational world again, which is not very scalable. So I need to pay for all the hardware for this relational database. No, not at all. It's still Spark SQL. It's still a good old SQL atop Delta Lake with Spark SQL. Okay, so let me show you create table. So something like so what are the tables? So first of all, let me do something like show tables. Okay, so I'm gonna show you all the tables that are registered in my metastore, in my Hive-like metastore, okay, which is called Spark Warehouse. So no tables. So let me create one. Okay, so create table. Let's call it D01 or Delta 01, and let's have it ID, and this is long with name to be of type string, using, and this is the moment where you say, hey Spark, use whatever you are supposed to use using this Delta Lake extension. Okay, and let me execute it, hoping that everything is fine. And now after executing this command, well, I'm expecting to have at least one table. Yes, and that's correct. So can I read this table? Oh yeah, why not? Spark table Delta 01 show, and I'm gonna show you all the, well, there are no rows inside because, well, it was just a shape or just a storage for my future data. So for the time being, we've got nothing really interesting. So let me save something to this. Well, let me insert something. So Spark range. Well, let me do this way. So sequence of 0, 0, and 1, and 1. So I'm just faking some data to be written to this, and this is ID, and this is name. So I'm gonna write it to using format format delta and save as table. And let me check. I'm not sure whether this particular command succeeds. My notes got lost for a moment. Probably we need append, because write format delta does not really say whether we are inserting. There is also insert into. By the way, why am I not using insert into? Insert into, yep, Delta Lake, and that's all you need. So we are basically inserting into Delta table of name Delta underscore 01 two records 0011, so well, two records of the shape, ID and name, and we write it in format Delta to this Delta table. So let me check. Well, yeah, it succeeded. Thank you. And by looking at this, at these logs, you can see that we've got version 1 this time. Okay, so let me read this latest and greatest of this table, and now you see that we've got the very same Delta table we had previously, speaking about shape of this data, but well, we've got this two extra rows. Now again, do we have show or describe? Sorry, describe. No, show. Describe. Sorry, describe. Oh, this is what I wanted. So describe table, and I'm gonna use this table, and I'm gonna show truncate false. So show me that all the niceties about this table. Well, as you can see, this is just basic SQL command. And now I'm gonna say describe extended to know that I am really working with Delta Lake, okay, or through Delta Lake or Delta table. So now this provider is Delta, so I know that this particular table is a Delta table. If it's Delta table, now we can expect history. So let me describe history of this. And by using this extension methods, extended SQL, show history, no, describe history. I'm always confusing show history, describe history. Describe history, I think it's show history, but we'll get to it, okay? Show truncate false. No, it's describe history. Nice. So version timestamp, exactly what we got by using Scala API earlier. Now it's SQL only. So for people who are familiar with SQL, it might be much easier, much better to absorb and work with than Scala API that requires some programming expertise. Okay, so you've got some information, meta information about who did what and when, basically. Okay, you've got these versions, and again, the obvious question is how to access zeroth version, initial version, while we are at the latest and greatest, which is first version. So second, while speaking about how many versions we have, we'll get to it. Again, if it was more interactive session, I would ask, do you have any questions? I'm pretty sure that you've got some questions and you put them in this Q&A or chat window under this window where you see me. Or that's what I was told. Okay, so let me switch to my slides and talk about yet another cool feature of Delta Lake. We are 43 minutes after we started this presentation. Hope you liked what you saw so far, what you've seen so far. If not, I'm hoping that this slide and demo that follows will bring your better mood. Excuse me? Okay, so Delta Lake and timetable travel. So time travel by version or timestamp. This is what Delta Lake supports out of the box. Meaning, you can just say, "Hey, Delta Lake, give me a Delta table at particular version, or give me whatever version was available after this timestamp." Okay, so you can just use version-based table access or timestamp-based version access, so to speak. I just made it while I'm presenting, so I apologize for this made-up word. So we've got time travel available for Scala, Java, Python APIs. By using these options, version as of, they are case insensitive, so you don't have to worry about having A and O uppercase, and timestamp as of. There is no support for time travel in open source version of Delta Lake. It's only available in Databricks version. I apologize for this. So if you find documentation that say, hey, you can use time travel using SQL, well, just remember this is about, this is about Databricks commercial offering. And by using this table identifiers in paths, you can access your Delta table at version by using @v particular version or @timestamp, which basically resembles whatever you could use for version as of and timestamp as of. Okay, if it's not clear, I'm hoping that this demo is gonna make things clearer. So let me switch to my, so what are we going to do now is you are going to learn, hi, my son, you wanna join me, the presentation? So in this demo, you will learn how to review the history of a Delta table. And I'm going to show you how to read a specific version of a Delta table. Now you know, now you should be aware of history of your Delta table. And this is the time where you learn how to switch between versions. Okay, so, yeehaw. So we imported this Scala API, this programmatic interface. So by doing import IO delta table, you've got access to a management API using your favorite programming language. For example, Scala. It could be Java or Python. I stick to Scala. I'm more comfortable with Scala than the others. And then you just do val dt delta table for path. You can also do something like for name for catalog registered tables, and then you just load it and you review available history, which basically is the same what you could do with show table or describe table. Now I forgot how it was, which one was okay. So 0 and 1. And these are the timestamps you could use and other meta information. Okay, so this is the history. So now we know that we've got two versions. So let me describe this history by using SQL. Now I've got my notes and I know that this is describe history. And this is pretty cool to refer to Delta managed tables by using this special catalog-like identifier. You may have seen these identifiers for specifying tables in particular schema or database. It's used for in Spark for accessing different formats too. So TMP, hop, and this one, and obviously truncate false. Okay, it's the same. So this one is the same what was available here. Okay, so same commands, but for different people. By different, I mean some people prefer Scala over SQL, and there are others who prefer the opposite. Okay, so Delta Lake doesn't mind. So time travel. So how to do time travel? Remember, we are going to use this version as of option because, well, SQL support is not available in this open source version of Delta Lake because of some changes that are needed to Spark. They managed to do this. Databricks managed to do this commercially. It's coming so soon to be available in Delta Lake, open source version Delta Lake 2. So Spark read, again, format, don't forget this. I remember I had my live coding sessions where I forgot this Delta and nothing worked because, well, time travel is only available for Delta tables. Well, so if you skip this format Delta, well, basically you are not leveraging, you are not using time travel that's available by using Delta table. And then option, and I can say version as of and say 0. Okay, we know that there are two versions, 0 and 1, and then I just load this table. Ta-da! And boom. Okay, so as you can see, Delta Lake updated the latest version cached of this Delta table. And now we've got whatever was available at version 0. Okay, you want to see this big table or big, large data set managed by Delta Lake at version 1? No problem. Just change version as of to 1, and now you see 4 records available. So look at this. The only change between these two commands is this version as of. All the rest is pretty much Spark SQL. So again, this opening question about relational databases working with SQL, whether it brings us back in time to this times where data was limited in shape and size. No, it's not the case. We are in big data world with tons of data stored on blob storages on cloud on a cloud provider or cloud providers in a cloud. And now by using Delta Lake, by extending Spark SQL, you can just access whatever version you need. This is especially important for cases like GDPR, case-sensitive information, which you'd have to remove from your history. You can just go back to whatever was available at version 0, remove sensitive data, redact them, and just follow along or follow on with the changes as if they were available initially. So all this is available over large data sets again. Okay, so you can also do this by using table identifier, by using tables that are registered that are not registered in catalogs. As a matter of fact, I just did this, but I'm gonna show you yet another API that you might find more meaningful. Okay, so by saying delta and by saying this, by using this weird looking for some table identifier, you just say, hey, Spark table, use this delta format to access this directory at this v0 version, okay, load it and show the content. Hopefully everything is okay. Oh, yes, I just type it and I'm still worried that I might mistype one command. So far it was okay. We've got 7 minutes left before we finish. So if you've got any questions, please let us know in this comment chat window. So this is version 0, and I'm going to change it to version 1 and show you that, for version 1, we are supposed to have 4 records, and yeah, we've got them. So you can compare, you can mix and match, whatever version you are interested in. So yeah, that's as easy as specifying the proper path just to, go through Spark SQL checks, which are general for all the formats that might be available in Spark SQL. But there are other Delta Lake-like solutions like Hoodie or Iceberg that provide similar features, and all of them use the very same extension APIs to be available in Spark SQL workloads and streaming and batch workloads. Okay, so that's pretty much it for the demo. So let me go back to another demo, which I just did just for the conference, Smart Data. I've never showed it before. I like it because that just opened some use cases I haven't thought before. So I'm gonna just finish up our presentation, my presentation of Delta Lake, by showing you the very recent demo, which I published just today, how to label commits with some extra metadata, user-defined metadata. So rather than me just typing it all, I'm going to show you my internals of Delta Lake book and show you here. So this is a demo. And as you can see, we are going to use user metadata option. And this option allows you to label your transactions, your changes, okay, basically. So whether you are doing merge, update, delete, or insert, they may have extra user-defined metadata. And by using this option, well, you can just label all the changes. And this tip I just left for people who are brave and brave people, brave souls, because, well, that just made me think about cases where there are different streaming write queries which could get labeled all the commits separately. So very fine example could be to distinguish what were the commits from one stream versus the other. That's one way to do this easily. So creating data table, now you know how to do this. It just write Spark range 5 just to create fake data, write format delta, and we just save it to a directory. This directory is tmp delta demo user metadata. We described history as we have been doing so far by using Scala API. Now you know that you could have also used SQL for this with describe history. So by doing history, select, give me 4 columns, something that I'm interested in, version, what operation made this change, what were the parameters, and user metadata. As you can see, user metadata, default user metadata is empty, which, well, is shown as null. Sorry, null sensitive people. Now we are going to append data, and by using this user metadata option, we will label this change with our custom marker, something like I just made up 2 more rows for demo. Okay, and since we are using append, I'm just importing save append. So our query looks like this: Spark range x2 extra rows are written using delta with this extra user metadata in append mode to our delta table. And by doing this, look what we ended up with. We basically created yet another version of our delta table with our custom user metadata. So this user metadata is something that you can you can just make up for your needs. It could be, a JSON, YAML, pure string, pure text, whatever you want to have as part of this metadata and written as part of transaction is gonna be, it's gonna be used, can be defined by user metadata option. And by saying, hey, show me all the records that are with user metadata is not null, I just basically showed the recent version I just wrote for the demo. Okay, again, if there was more interactive session, I would just ask, do you have any questions? Questions are coming. There's one last minute of me talking, so answers are coming. Okay, so let me switch to my slides. Slides are here, and I was going to show you yet another demo, but I doubted when I was creating the slides. I doubted that I might have enough time, and that's the case, so I skip it. For people who are interested, just go to the slides. They are going to be published at some point, and there's a link to to all the steps that are needed. Okay, for people who are curious about Spark and Delta Lake in particular, well, you can just grab this free of charge in a worth of $50 book, Learning Spark by people like Jules, Brooke, TD, and Danny Lee. They are Databricks, and they are very, very familiar with how to use Delta Lake and Spark effectively. So definitely worth checking out. Chapter 9 is focusing on building reliable data lakes with Apache Spark and touches Delta Lake as well as competitors like Hudi and Iceberg. Okay, there is also VLDB, Volcano database paper conference, Delta Lake high performance ACID table storage over cloud object stores. Very fine reading, so it can extend what I showed you. And that's pretty much it, because you know where to find all the niceties I shared today during this presentation. This is the internals of Delta Lake of mine, where I'm describing all the findings after me spending time with the source code of Delta Lake. That's all, folks. Thank you so much. Спасибо большое. Говорить по-русски в порядке? That was something I just reminded while speaking to you guys. So that's all, and I'm ready for questions.
Thank you very much, Jacek. It was really a very interesting talk, and we have a lot of questions in chat. And the first question is actually about comparison with Apache Hudi. How does the Delta Lake compares to Hudi, and what are pros and cons?
Very nice, good question. And when I say I really mean it, I can't answer this question because I just started exploring Hudi and Iceberg. Know nothing, almost nothing. So I'm far from being ready to answer this question. So, so answer is coming. Sorry for this. There are some cool features of Hudi that are not available in Delta Lake. It seems like Delta Lake is more mature, but yet feature-wise might not be better than Hudi. So you'd have to check it out yourself. Sorry.
Okay, I see. And maybe a question from me. What is actually the niche for the tools like Delta Lake? Because, in Spark, we are used to work with immutable data. So we are only appending and we're using this data for analytics. And what's the niche for Delta Lake and Hudi? Is it... I don't think it's like online transaction processing. Is it for data analysis or what kind of?
Very good. Yeah, very good question. Thank you for this. This is for cases where you want to apply the same principles as you do to your code, source code, while using GitHub, for example, or Git in general. So you version your code. So why not to version your data? And the beauty of thinking like this is that your data should also be covered by the same principles as you apply to your source code. Why not? And so, yes, you say, we are only appending. My question is, why are you only appending? Why not to manipulating your history? Well, it happened in history. Why not to modify our history to make it better, hopefully? And so things like GDPRs, they just said today, hey, the rules that European Union and other countries accepted, they say, whatever you stored so far, whatever you appended so far, have to be modified to match GDPR or GDPR-like rules. So now, when you say we are only appending, well, again, repeating this acronym, GDPR made things a little bit tougher because you have to change your append-only datasets with these rules, with these new rules. So you have to version your data because at some point, if you start modifying your large datasets, well, you may make mistakes. And that's the niche.
Okay, so with the GDPR case, I might need to delete info about some user. but it will create a new version of my dataset, and the user will still remains in the older one, isn't it?
Against GDPR.
Yeah,
It's the
and then it will be against GDPR because I had the user in the previous version of my data, but not in the new one. But I still can access the previous one.
Thank you so much for this. First of all, you could limit who can access previous versions, correct? So now we are thinking about security. Is security available? I don't know. I'm not aware of any solutions for Delta Lake that would limit, what version you can access. But second, option that's available right now, it's vacuuming, deleting, not only logically, but also physically. So yes, you're right. We are creating brand new version of our data. But if there is a need to wipe out all the entries, all the historical entries up to a certain point, you can just do delete, correct? This is just logical marker. And then you do vacuum, something I haven't showed during this presentation. And by vacuuming, you can physically remove all data sets, all the previous versions, which basically is exactly what you wanted. And yes, you're right, we are losing history, but this is exactly what you asked for.
Yes. And
Jacek, me too have a question for you. I see that Delta Lake can be suitable in case when you have I don't know, some kind of a data stream which you are writing to your object storage, and the schema of this data stream changes, I don't know, a couple times of a year or every month. Let's name it like every month. And what I would like to do is to somehow like query this data by versions from SQL. For example, from Presto, you mentioned it earlier. Like I want to query a table version with the version number 3 and after that I want to run query on version number 6, and the schema of both of these versions are different completely. That's the first part of the question. And the second part, is there any like automatically schema merging when I want to query a couple of versions?
Very nice questions. And you see, after this presentation, looks like I presented Delta Lake in a proper way, because your questions, guys, are exactly, they prove that you understood the role of Delta Lake, and your questions are just doubts. Is it possible after having heard all the features? So Presto. First of all, Presto do support Delta Lake in enterprise version provided by the company called Starburst. I haven't looked at this Delta Lake support in Presto because, well, it's a commercial version. So, and I'm for open source version, so I haven't looked at this. I know that Presto can query Delta tables. There is this direct support for Delta tables, so I assume they somehow handle different versions, and they know how to deal with these differences because, well, that's the bread and butter of Delta Lake. So yet I can't claim I've seen it in action. Second, schema merge. Yes, there is schema merge. I haven't showed it because, well, we run out of time, and there are few other features that you haven't seen. So schema merge can be, first of all, automatic. So whenever you change your schema, you can just say whatever happens next should be applied automatically, meaning we moved with our schema in whatever direction we want. We can just force that it's more like evolution rather than revolution. And then if you want to compare different data sets, well, it doesn't really it does not change much in terms of how Delta Lake works when you forget about Delta Lake and start thinking about different data sets. They've got different shapes, and now you want to compare them. What would you do? So that's basically it. So Delta Lake just showed you that there is this problem of comparing different versions because, well, I triggered this thinking by showing you features of Delta Lake, but the very same question would be very fine and applicable to any other data set, not necessarily Delta Lake managed, correct? So, yeah.
Yes, and we have a few more questions regarding more detailed technical feature. For example, does the Delta Lake supports upsert using composite case? Because the questioner claims a year and a half ago it was not supported. Do you know
so
right?
I'm not really sure if I understood this composite case, what it exactly means, but I'm going to show you one demo that I have here. No, it's not here. So let me zoom out a little.
Speedy, because we have a
time limit. Yeah. No, I'm not gonna live code this.
Right.
There is this. Yeah. So merge operation, and in merge operation, something that was supposed to be presented, but I ran out of time. Well, there is support for merge into. So this SQL command merge into is supported. This demo showed it from Scala API, but it's also possible from SQL. So as you can see, I'm using something that's called merge builder, and I say when matched, well, do something with it. And among the actions I can apply to do something with it, to rows that match, is to just delete them. You could just update them. So it's kind of like upsert. So if you are thinking about upserts, yes, it's also possible. So you can insert rows that are not available by given keys, or update already available keys, already available rows with new data. Yes, if it's what was asked for, yes, so this is supported.
Yes, I think the question was about upsert, but when the key is not just a primitive type, but rather a struct.
It doesn't change much. If you can write a query in Spark SQL and display the changes that you want to apply your new data to, or just somehow create a query, SQL query, if it's supported by Spark SQL, it is, or it's supposed to be supported by Delta Lake 2.
Yes, great. So I suppose we can go to the discussion zone.
Yeah.
Now we have
Thank you for your talk. Thank you, Dmitry, for your patience and your like job reviewing questions. I welcome you to the discussion zone in Zoom, and everyone who's watching us also come there, and or stay with me to know what we seen today and what will wait us tomorrow. But I strongly recommend you to join Dmitry and Jacek in discussion zone.
Sure. Thank you so much. Спасибо большое.